So quick thought experiment. Over here there's a galaxy. This galaxy is big and far away. And its light goes out in all directions. We're just going to talk about the light coming to our big telescope over here in Jerusalem. I mean, this is amazing galaxy. The galaxy, we're watching it, is really interesting. But we don't see it lifetime, right? We see it only if the light reaches us, and that could be millions of years or billions of years, depending how far away the text is. So let's just think. I'm watching this galaxy, and it's real interesting. Now on the galaxy, something is happening. The stars are evolving, and some of them explode. Supernova. Boom. The light goes out of that supernova, this huge, an exploding star. Huge burst of light in all directions. We're just going to talk about the light coming towards us. It's the same in all directions. Supernova. A week later, another supernova. Two supernovae. The first burst travels a whole week, and then the second burst. So now the burst of energy has traveled, this peak of light has traveled, and 1 week later another. But now as they travel through time and space, what's the universe doing? Getting bigger, smaller, standing still what? Expanding. So what are the space between the bursts? Increasing. Let's say the universe doubles in size, okay? It's now twice as big by the time the light reaches. So here it's a week apart first and then a week later. But now it's twice as far apart. The first burst hits the telescope. Oh, a supernova, break up the beer, friends, let us celebrate. That's what we do. What would the second burst? Would it be a week later? Well, if now the distance is twice as much, how much later would the second burst reach us? 2 weeks. 2 weeks. I look at, my perception is those bursts, those explosions of stars were 2 weeks apart. I want to know what it was back then. Well, that moment doesn't exist by billions of years in history. But I can call up an astronomer, and he can tell me how far away that galaxy is. It may not even exist any longer, but how far away that galaxy is, how much space is stretched. And now I go back in time, taking those data. And as I go back in time, the universe is getting bigger or smaller. Mathematically, of course. Smaller. And the 2 weeks become 1 week. Two perceptions of one reality. And that is exactly what's here. These years went by. How will they be perceived? The operational word here is perceived from the Bible's point of view. And for this, Nachmanides makes a nuance. He says, he writes, time is created at the creation. That's the Kabbalah. Time is created at the creation. Aquinas says exactly the same thing about the same. Time is created at the creation, but then Nachmanides makes a nuance for the calendar. He says, however, Mishia Yesh Yifos Man. When you have matter, because he describes the first creation as Dakmod, Ein Bo Mamash. It's so thin, there's no substance to it. They call it energy. But then he writes, Mishi Yesh, when you finally have Yesh matter, Yefospo, Tofes means what? Grabs a hold, that time grabs a hold, which is literally true also. And the calendar begins with time grabs a hold. Now that E to M transition, as Einstein said it could happen, took less than a second. It's about 100,000th of a second. It's a big approximate sign here, but that's approximately we estimate it to be. What's interesting though, this is the first moment in history of the universe that we know absolutely. Everything else is very good science, very good predictions, but this we know. This we know because of the energy level that it takes, that is required to have a massive energy condensed into a particle, like a proton. In fact, that's what is the proton, the energy of a proton. We know this number here by measuring the black of space. So if I could predict how much space had expanded from here to here, if I could measure or predict how much space had stretched from here to here, I could make a calculation of how the 14 billion years would look from this perspective. Just like with the galaxy, I knew how much space is, an astronomer told me a factor of 2. I'm measuring 2 weeks. I go back and it becomes 1 week. I want to go back in time to here. What's important about this approach you're about to hear is one of the 2 leading peer-reviewed journals in the world, Nature. One is called Science, it's published in the States. My background is MIT, and then I got published regularly in Science. Well, not, of course, it's an American paper, but that was the type of work they report on. Nature, the journal Nature, one of the 2, published in the British Isles, it's one of the 2 leading peer-reviewed journals in the world, uses this identical approach for a different purpose. But this idea of having these 2 perspectives of time. They use it for a different purpose. They don't mention Schroeder, of course. God forbid, they never mention God. But they use it, which gives it the stamp of approval, because it's important that this peer-reviewed journal, which is one of the 2 tops of the mountain, Science and Nature, accepts this as a way of having 2 different clocks. And that's what the Bible was doing 3,000 years ago. Day 1. Why not the first day? Because there hadn't been the second day. Thank you, Nachmanides, for that insight. How would the 14 billion years look from here? For that, I would have to know how much space had stretched from here. The moment when matter forms is called nucleosynthesis. Nucleosynthesis, the forming of nuclei, to here today. And we know that ratio by knowing the temperature that nucleosynthesis occurs initially, and the temperature of the black of the sky of night. Not the temperature of a star or a galaxy, but the sky is primarily black at night. It's empty. You measure that temperature, and that number is known, and that ratio is how much space is stretched. Every time the universe doubles in size, the wavelength is stretched out by a factor of 2. Triples in size by a factor of 3. That number, the ratio from here to here, is 900 billion. It has nothing to do with discovery, nothing to do with ancient Torah, nothing to do with Schroeder. It's a number straight off the textbooks, okay? 900 billion. It's a totally non... I don't think anything is secular in the world, but let's put it this way. It's not a theological number. 900 billion. It's a unitless number. It's a ratio of 2 temperatures. Just what unitless means is a quick example. If I have 10 degrees and I divide it by 5 degrees, what's the answer? 2 what? 2 what?
2. Just 2.
Why just 2?
Because the degrees cancel.
Because the degrees cancel, exactly. It's unitless. It's exactly, and this is the temperature ratio also. It's a unitless number, which means that if I had 900 billion seconds worth of history, I don't know, the cavemen or something, it would be 1 second, it would be viewed as 1 second from here. Billions and billions. 1 second. All the information is there. It's just a video, super fast story. 900 billion days would look like 1 day. 900 billion minutes would look like 1 minute. None of the information is lost. It's just all compressed. And 14 billion years, well, that's kind of interesting. How do we, what would that look like if we compress the 14 billion years? Because that's what I have to take. I want the Bible's perspective of time. At 14 billion years, compressed by 900 billion. It's so magnificent. It could have been any number under the sun or above the sun. But it comes out to both be billions. It's so interesting. After a while, you wonder about these nuances. Maybe they really aren't nuances. Maybe they're the reality. Of course, now, 14 years, the zeros drop off, divided by 900. So I have 14 years divided by 900. Gives me the age of the universe from the Bible's perspective of 15 thousandths of a year. I mean, friends, to get hung up on 15 thousandths of a year, give God a break already. It was almost nothing. It's not quite nothing. It's almost nothing, but not quite. Because we change it into days. You know what we get? You get 5.5 days. It's almost embarrassing. There's no trick to that. I didn't choose the number. The numbers of the textbook. I brought one thing to the party. One thing to the party. I said, we know the numbers now.